Okay, so question 3. Use an algebraic method to find the square roots of 3 plus 6 root 2i. Give your answer in the form x plus iy, where x and y are exact real numbers. We've not done one of these, have we? We've not talked about this when we were doing this, but remember how we set this up. We're saying if x plus iy is a square root of that, then it must be true that x plus iy squared is 3 plus 6 root 2i. Does that make sense? Because that means that x plus iy is the square root of 3 plus 6 root 2i. So that's how we're setting this up. We're setting this up as a little equation for us to solve. We're going to square this side, we're going to multiply this out. And that's going to give us x squared. When we multiply it out, we get an xyi, and then another xyi. So plus 2xyi. Looking forward to maybe John teaching some of this at some point. That would be good. And then we've got iy squared, which would be I squared y squared, which I'm going to write like that for now, because it's fun. So what we've ended up, this bit, I squared y squared, is actually minus y squared. So we have x squared minus y squared plus 2xyi is 3 plus 6 root 2i. And now we compare real and imaginary parts, because we've got this bit on this side is real, and so is that. And this bit is imaginary, and so is that. So we compare those bits and see what we can get from it. If we compare the real parts, we've got x squared minus y squared is 3. If we compare the imaginary parts, we've got 2xy equals 6 root 2. From which we have to end up with values of x and y. But we've just got simultaneous equations to solve now. They're not the nicest of simultaneous equations. But we're going to say from this one that y equals 3 root 2 over x. I think that's right, isn't it? If we divide both sides by 2x. Is that wind or thunder? It's wind, isn't it? So if we substitute it back in, 3 root 2 over x squared is 3, giving us x squared. Now what is that? That's 3 root 2 in the square is 9 times 2, so 18 over x squared is 3. Which if we multiply through, we get x to the 4 minus 18 is 3x squared. And it just makes you think, doesn't it, how far you've come from simple core 1 stuff. Because, you know, we're kind of casually, as part of a much bigger question, finding ourselves with this stealth quadratic, isn't it, which in core 1 terms is quite a difficult thing to do. So we need to solve this. Does it factorise? 18 is 6 times 3. So that's looking quite good, isn't it? Does that work? Can we leave it in terms of x squared? X squared minus 6, x squared plus 3 equals 0. You could do a substitution and use t or u or whatever letter you like, but we can leave it in terms of x squared, giving us x squared equals 6, or x squared equals minus 3. Now, the idea here is that x and y, I don't know if you said it, yeah, x and y are real numbers. So that's an important principle. X and y are both real, so this one gives us no real solutions. So we're left with x squared being 6, so x is plus or minus the square root of 6. Now if we go back to our start point, we had y was 3 root 2 over x. So we need to work through with that. If x is plus root 6, y is 3 root 2 over root 6. And you could probably just stick it into your calculator, because you've all got calculators that will deal with that nicely enough. The 2 and the 6 cancel out, so it's 3 over root 3, isn't it? And I think we ought to know that 3 over root 3, if you rationalise the denominator, is just root 3. And then if we do the minus 1, we're of course just going to get the same thing, but negative. Because the only difference is we've got a negative number in there. So there you go, there's your solutions. The answers are, what did they want us? Did they just want x and y? No, give your answers in the form x plus I, y. So we've got, the answers are root 6 plus I times root 3, and minus root 6 minus I times root 3. Or root 3i, doesn't matter which way around you write it. There we go. Great. Happy with that? Brilliant. One thing, it's probably not worth saying, but one thing just to mention, occasionally we have people mention the word conjugate in terms of this, as in, you know, the answers to the square roots of the complex conjugates. It's really important to remember that they're not. These are not complex conjugates, are they? One is minus 1 times the other, they're not complex conjugates. So that's quite a big deal. Are you alright, Amy? Right. Oh, and that's maths.